Okay, today we are going to discuss about simple linear regression, and the model, it is this one of a simple linear regression. This is the model that y it is equals to beta naught plus beta 1 xi. This one arise where y is the dependent variable, beta naught and beta 1 are the coefficient of the model. Yi or xi is the independent variable, or you can, it is the regressor. For example, finding beta naught, we usually say beta naught is equals to y bar minus beta 1 kappa x bar. And what is x bar? X bar, it is the mean of the xi's, where you get the mean of xi's by saying a summation of xi's over n over n. Even for y bar, it is the mean of yi's. Beta 1, it is the summation of xi's minus xi minus x bar, yi minus y bar, all over the summations of the xi minus x bar squared. These ones are the coefficient of the models, and that we are going to fit them. And you can calculate this one manually through using these formulas, and even you can use R software to calculate. For example, we are going to fit a simple linear regression using R software. So let's do it right away. Yeah, for example, you can see in your screen that we are going to use the data from Orange, data which is called Orange. This one, it's always provided by RStudio. This is the RStudio environment, and we are going to call it my data, the Orange data. So let us see what it shall provide as we continue. Yeah, for example, now, okay. Now let me share my screen with you. Okay, I'm going to share my the RStudio screen with you right away. Okay, this is now the RStudio environment. For example, now we have seen that we will be using Orange data. You can find out what Orange data consists of. Orange data, you can know what Orange data consists if you just ask. Yeah, you can ask from the, okay, you can ask what is Orange data, and let's see what will the output Orange data from the helper. This is the help. So the Orange data has 5 rows and 3 columns, and it consists of, you can see that the variables that it contains. It contains 3 variables: the range and the circumference. Okay, having known that, so we have to, of course, in a fitting a linear regression, you have to have x and y. So but you'll need these packages so that we can continue. So let's run them first of all. At the end, my data, it's showing me a sample, or just the the first three of the value of the observations. Yeah, for example, you can see that age there's 118, circumference of 30, and so on and so on. So let's go to rounding our packages. Yeah, we will use ggplot. This one will help us in plotting. For example, you will use plot, scatter plots, and so many things just to visualize our data. Okay, having done that, let's wait until it's okay now. Names, it shows you the names of the observations or the names of the variable that we have in our data. You can check even the structure. The structure of your data, it is important because you can, in regression, we usually use numeric values. So you can check your structure. So you can find out, for example, the 3 is a factor, but in our case, we will be using a circumference and range, which are both numeric. So we don't have to change anything there. So right away, we are going to model a simple linear regression model, which you can model it by saying ln circumference inch my data. Now your data, remember you had called our data up there, my data, which is orange. So let us run it. So run as we run. Yeah, but let us see how our model is. You can see the coefficients, the beta naught and beta 1, you can view them here clearly. As I had told you, you can calculate them easily, very easily. So you can even extract them by saying coef of the model, and even you can see the summary of the model. In the summary of the model, you'll know which coefficients are significant into the model. For example, if it is indicated by 3 stars, you can see that that one is highly significant in the model. So even you can find the R squared. The higher the R squared, the better your model. So having known that, we will go right away to just plotting some scatter plots, so that we can see the relationship of the circumference and range of the orange trees. So right away, let's see what we do. So wait until it run, give it some time. What environment? Yeah, you can see now it has shown the relationship which is between circumference and range, but you can enable these features by saying alpha, it is the alpha, setting alpha is equals to 0.95. It is the contrast, or the contrast of the points. The color, we have set it as rendered, as you can see, and the shape, we have seen the user, the one that look like a diamond. But all these, they are not very much important. You can just have your simple scatter plot by just saying like that. Those ones are not important, and see, we have that one. You can answer features, your title. You can add it, and many other. So you can even construct a line, a smooth line, or from our data by saying ggplot mapping. These are the your axis. What do you intend your x-axis to be and y-axis to be? So let us see what you have. Okay, let's give it some time to learn. And remember, you can even add some features here. Not features, some things like the way we had seen alpha to be 0.95, color, and so on, and so on. And even you can remove this one. the error by saying error is equals to 0, and method to ensure that your method, for example, you can say sin is equals to 0. Let's see what it will give us. You see, there is now the weakness or the error that it was giving us are just disappeared. So you can even when using a smooth curve and use a straight line or let's call it a line of best fit by saying method is equals to lm. You see now, let's see what it will give us. You see, let's see what it is giving. A little bit, let's like you are not, yeah, like that. You can see it has given us a line of best fit. You can even change the color of the line by just allocating your best color that you like. For example, you can say color is equals to, you can say even length, you see, just the one that you like. Let's see what it means. For example, you can have color to be red. Yeah. You can see now, that's how you can do some data visualization with R and extracting your beta notes and even the beta one. Yeah, thank you for watching, and subscribe to my channel.